Welcome back, friends. We are in discussion of price elasticity, in which we are discussing the second topic called point elasticity. What is meant by point elasticity? Point elasticity refers to a measure of elasticity at a given point on the demand curve. Now please check this point R, which is on the demand curve, y-axis being of price and x-axis being of quantity. Now what happens to point R vis-a-vis change in price, which is a very small change leading to the implications on quantity demanded. So we have a basic formula which explains point elasticity, which is lower segment divided by upper segment. What do you mean by lower segment? RT divided by R small t. Refine it, R capital T divided by R small t. At this point of elasticity, wherein the price differential is very minimum. Please check the note that I have given. Point elasticity is used for measuring EP where change in price is infinitesimal, that is a very small change. How does it work? Please come to the second graph, wherein y-axis is represented by price and x-axis is represented by quantity. How do we do this? Please check that RT divided by R small t will give one of the point elasticity. I have given you 5 different varieties to arrive at point elasticity. That is depending on the point of the demand curve where we want to find the elasticity. That is the responsiveness. First one, point elasticity at point R. That is R capital T divided by R small t, where E, that is elasticity, should be equal to 1, because this whole thing divided by this whole thing should be equal. Numerator lower base and denominator upper base, or lower segment divided by upper segment. So it looks like on the freehand diagram that R capital T divided by R small t will give me the same measurement, which means the elasticity is E equals to 1. And the second point, point elasticity at point L, that is this point. How do we measure elasticity here? Lower base LT divided by upper base L small t, which is LT divided by L small t, giving an answer or leading to elasticity being lesser than 1, which is quite logical. Please observe the distance of L capital T and L small t. If L capital T is of lower distance and L small t is of higher distance, numerator being L capital T, obviously the final answer should be elasticity being lesser than 1. In the third case, point elasticity at point S. Point S. How do we arrive at point elasticity here? S capital T divided by S small t, that is lower base divided by upper base, or lower segment divided by upper segment. Obviously it leads to E greater than 1. Just as a matter of substantiation, please check the distance of S capital T is greater than the distance of S small t, which means the denominator is lesser than the numerator, or should I say denominator or numerator is greater than the denominator. When numerator is greater than the denominator, obviously I am going to get E is greater than 1. Further, point elasticity at point T. At this point, what is the responsiveness? We apply the same formula, that is small t to capital T being the lower base, small t capital T divided by TT upper base. So total of small t to capital T distance divided by small t distance, which is at 0, we get infinite as elasticity. It's quite logical again. When anything is divided by 0, we end up getting infinite as the answer, the elasticity being infinite. Lastly, point elasticity at point T, that is capital T. Now if we see capital T, then lower base is TT, which is 0, divided by capital T to small t. The distance between capital T to small t has some value, but the distance of TT, which is the lower base, has a 0 value. When something is divided, or when 0 is divided by something, then the final answer mathematically leads to E equals to 0. Now in my next session, after discussing arc elasticity and total outlay method, I will also explain the interpretations of what is meant by E equals to 1, E lesser than 1, E greater than 1, E equals to infinity, and E equals to 0. I hope you have understood when we have to use point elasticity. Summary: point elasticity is used only to measure the elasticity at a particular point on the demand curve, and whenever the change in price is infinitesimal, that is very small change. I hope you understood this. Thank you.